All right, let's quickly take a look at some more problems in the definite integral problem set. The next example here says, express the limit as a definite integral on the given interval. And we have the limit as n goes to infinity of the sum, I going from 1 to n, of e raised to the power x sub I divided by 9 plus x sub I times delta x on the interval 0 to 2. Well, let's quickly take a look at the definition for the integral. Again, before we jump in, we know that the definite integral from a to b for f of x dx is equal to the limit as n goes to infinity of the sum I going from 1 to n of f of x sub I times delta x. So we can really make that exact almost comparison here. So to kind of just get us started here, we can see that this component, this piece right here, is going to be the e raised to the x sub I over 9 plus x sub I. This is our function. And so we can simply go ahead then and write this using this definition. We will see that this will be the integral. The bounds are given here. So this is the integral from 0 to 2 for if f of x sub I is equal to e to the x sub I over 9 plus x sub I, then f of x will simply just be e to the x divided by 9 plus x dx. And that is all that there is to it for this problem. All right. The next problem that I would like to look at says, write the following expression as a single definite integral in the form integral from a to b for f of x dx. And we are given the integral from -4 to 1 for f of x dx, plus the integral from 1 to 2 for f of x dx, minus the integral from -4 to -2 for f of x dx. So again here, I would like to take a look at some of the properties of the integral. And the first property says that the integral on the interval a to b for f of x dx plus the integral on the interval b to c of f of x dx will be equal to the integral from a to c for f of x dx. All right, so we can add intervals together, and similarly in the next property listed here, we can see we can also subtract an interval out. So if we know the value for the integral from a to c, we can subtract out the interval from b to c to get the interval from a to b. All right, so right here, I'm going to start with a number line, and maybe let me use a highlighter here. So if we have the value for the integral from -4 to 1, so let's say we know that this value here, we add to that the integral from 1 to 2. I'm sorry, the previous one from -4 to 1. I didn't shade it all the way. And we're adding to that the integral from 1 to 2. So together this will be the integral from -4 to 2. But now we want to subtract out the value of the integral from -4 to -2. So really what I want to do is kind of cancel out this piece right here. So all we will have left would be this piece right here. All right? So this would become very simply then just the integral from -2 to 2 for f of x dx. All right, so another problem here says, if we know that the integral from 1 to 7 for f of x dx is equal to 8.2, and the integral from 6 to 7 for f of x dx is 3.6, can we find the value of the integral from 1 to 6 for f of x dx? And again, I'll quickly just put that same list of properties up here. We're going to use the same properties that we saw in the previous problem. All right. All right, so the first step here would be to say, all right, according to these properties, the integral from 1 to 6 will be equal to the integral from 1 to 7 minus the integral from 6 to 7. So for my specific problem, this will be 8.2 minus 3.6, which will be equal to 4.6.